I'm Randy Stone. In February 2003, I was the Deputy Center Director at the Johnson Space Center. After the accident unfolded later that day, I was named as one of the leads of the NASA Accident Investigation Team, along with Frank Benz and Jim Kennedy from the Kennedy Space Center. On that morning of the Columbia reentry, I was in the viewing room with most of the shuttle program people and four ex-flight directors and the center director, General Howell. The four flight directors that were in the control center that day with me just happened to be the four flight directors that worked together with me on the Challenger flight. It was the Ascent Flight Director, Jay Green, one of the Orbit Flight Directors, Lee Briscoe, the Planning Shift Flight Director, Chuck Nahr, and myself. It was probably the first time the four of us from the Challenger accident had been in the same place at the same time. And so it was just one of those ironic days. You know, we were there to celebrate Columbia's return. And as everyone knows, the day started downhill fairly quickly as instrumentation on the vehicle started to fail. I turned to Lee Briscoe, who, besides being an experienced flight director, a close friend, and I said, Lee, this is not good. It has all the earmarks of a catastrophe. I turned to Beek, the center director, and said, General Howell, I believe this could be the worst day of your life. 2 or 3 minutes went by, and the reports kept coming in, and it was fairly clear to even the people in the viewing room that we had a tragedy in the making as more and more instrumentation started to fail. Our knowledge of the vehicle was such, we knew it was on different instrumentation buses, different MDMs. It wasn't a single point failure causing these data losses. It was multiple failures, and it was my fear that we had some kind of structural issue going on in that wing, and it came to pass that that was the case. So it began the worst day of most of our lives. Some of us had been through this before. A lot of people had not that were in that viewing room, including General Howell. And we knew we had a disaster on our hands. The flight control team went immediately to work to secure the room, to secure the data, and follow all the instructions. The building was locked down, and we stood there in silence for several minutes as the disaster unfolded. But it became very clear that all of the people that were in the shuttle program that were directly involved in the decision making to fly the flight, to continue the flight, in the flight readiness review, all had highly emotional ties to what was going on. It wasn't that they were doing anything wrong, but they had highly emotional ties to the vehicle, to the crew, and it became fairly clear that it would be appropriate if the program office took a step back, provided the technical expertise and the expertise to provide how the mission was managed, but a different group of people to run the day-to-day operations and start the analysis. And that was the beginning of the concept of the NAIT. Frank Buzzard had been named to the Columbia Task Force. He was the He was going to be the direct interface to Admiral Gaiman and the CAIB, but Frank clearly his team did not have the bandwidth to run the daily operations of the recovery and the search and rescue or the search and recovery efforts. So there was a decision made to put an executive board in place to run what the program had been running, the MRB, the daily activity of running what was going on in the field, and to begin the analysis that was going to be required for the CAIB and the task force to do their job. The NAIT into me doing the ops and running the day-to-day activities, Frank Benz doing the analysis, and Jim Kennedy following up on all of the issues with engines and tanks and SRBs, however they may have affected the ultimate outcome of the flight. When the NAIT was formed, it was really kind of a loose coalition between the three of us. I kind of got elected to be the leader of the group by consensus from Jim and Frank, and like I say, we divided the activity up between operations, analysis, and vehicle hardware. I had been a flight director for many years. I'd flown many flights as a shuttle flight director. I had intimate knowledge of the vehicle, and my strong suit is integration and asking questions. So that kind of put me in the right place of running the day-to-day activity. I can drive you crazy by asking questions until you have absolutely no more answers to give. And so that's kind of how the separation of powers came about. It was just a natural evolution for the three of our skills. The early hours of the NAIT, it was clear that we had never thought ahead far enough to recognize the need for this interim type group. What was keeping me up was how to keep the integrity of the team so we wouldn't be questioned later about covering anything up. It was my goal to make everything as transparent as possible. There were so many moving pieces in the early moments of this disaster that had to be coordinated and integrated, and it was a huge number of people. It was multiple centers. It was multiple locations doing serious activity. Let's kind of break it into the major pieces that number one concerned us first, the things that concerned us second, and then how we put it all together. Clearly, the first order of business was to recover the crew. Clearly, there was no chance of survival from the very first moment as the vehicle came apart. We knew that, but we felt a burning obligation to the crew, our friends, our colleagues, to recover the crew and treat them with the greatest respect as we recovered the vehicle and the crew. So that was my first concern. Dave Whittle had been named pre-flight as the guy, if we have an accident, he would go into the field and be the leader of the band. He had some significant training in accident investigation. He had been head of the JSC safety organization. So he had a very broad background to do that job. Dave is one of those down and in engineers that you want on any project that you've got going. And you know, if you read the history books, there are a lot of heroes out in the field, but Dave wasn't typically one of them that was mentioned. Because my feelings are so strong, I would like to make the statement that Dave was kind of the unsung hero of the recovery effort. He made all the logistics work. It became clear in the first 72 hours in the field that we had so many federal agencies working that we needed somebody with political astuteness and a high-powered exec to take all of the flack off of the working man's back out in the field. Dave King from the Marshall Space Flight Center was the guy selected to do that job, and he did a superb job. He got the credit he deserved for all of the things he did out in the field, but none of those things would have been successful without Dave and his team doing the day-to-day business down and dirty out in the field. Dave made sure that the astronauts who were part of the search team had everything they needed. The teams that were looking for hardware had everything they needed, and started pulling all of the pieces together as we started recovering Columbia that was scattered all across East Texas. The next big piece was what happened and how can we go and determine what happened. So we have a huge number of analytical tools, both at JSC and at Marshall, that were brought to bear. Clearly, the program and a lot of people surrounding the program kind of fooled themselves and us into believing that, yea, verily, foam could not have done this. But clearly, stepping back with 20/20 hindsight, it became, well, even as it started to unfold, it became clear that it doesn't matter if a material is light. If you have 1.5 pounds or 2 pounds of that material going 700 miles an hour, it's going to do devastating damage to any structure that it runs into. So we clearly had to prove that it was either foam or something else that fractured the structure on the wing. It became clear pretty quickly that hot gases got in the wing. We didn't know whether it came through the leading edge from a break in the RCC. We didn't know whether it came through a wheel well or an umbilical door had failed. We truly didn't know any of these things. So we had to start building a data map of what was going on in the vehicle. So at that point, we had the integration teams that were responsible for getting the vehicle ready to fly, start looking at all of the information associated with the tank, the foam, what else could have come off, what may have failed. As we were going into this investigation, it became obvious that we did not have enough data. The ops recorder, the data recorder, was lost in the wreckage somewhere. And so it's like the black box on an airliner that goes down. If you've got that, you've got tremendous insight into what went on. So for days, we were just kind of making assumptions and then trying to do the analysis that would say, could this have caused this accident? And at this point, the analysis was going fairly slowly because all we had was the data that we saw in the downlink before the vehicle came apart. And once it came apart, the power was interrupted and we didn't get any more telemetry. So we had a very limited amount of data. It was very telling data. You could almost track the disaster that was happening in the wing from the instrumentation that was going away, but it didn't give you enough information to know where the initial breach was. So those are the big moving pieces that I was grappling with right there at first. Had I needed to understand what went on at Johnson Space Center and how to interface with other centers, if I hadn't known that already, I'd spent the last 10 years of my career doing just that, working with all of the centers in the agency on getting shuttles ready to fly and flying them. So I had a good understanding. Without that, I wouldn't have gotten any sleep for the first month because I've been trying to figure out how to talk to people, who to talk to, where to go. We didn't have that problem because the three of us, between the three of us, we could reach into any organization in the agency. As the investigation moved forward, it was clear that we had a huge amount of circumstantial evidence that something had breached the structure of the wing. We had hot gases in the wing. We were finding pieces in different places along the ground track that would imply what came off first, what came off next, what came apart next. But we really didn't have anything but the circumstantial data. The major breakthrough in this investigation came when the OEX recorder was discovered in East Texas, and it was a true. I think somebody described it as one of those aha moments. We found the data recorder. If we can just get data off of this thing, this is going to confirm or not confirm what we think was going on. I think it was a true miracle that this piece of gear, one, survived, a hypersonic vehicle breakup and reentry and impact into the ground, and it probably impacted, if not supersonic, close to supersonic speeds. It was crushed. It was not serviceable, but the data was on the drive, and through my amazement, the folks were able to pull large portions of the data off the recorder, and it gave us a map of what was going on, and that more than likely the breach in the wing was in the leading edge of the RCC. We were kind of understood where it might have been on the wing, and at that point it became clear that we were going to have to either prove or disprove a piece of foam could fracture the RCC. That's when we set up a relationship with Southwest Research to provide testing. I went to the program and asked for the RCC flight panels, the spares. I believe it was two of the panels to be dedicated to testing, and clearly it was going to be more than likely destructive testing of a very expensive piece of hardware. But in my view, and in the view of everybody else in the program, we had to find that out. We had also done a bunch of analysis that disproved a theory that people had some months before, several flights before, that foam, even if a large piece of foam came off the tank, it couldn't get to that part of the wing. but refining the aerodynamics and refining the analysis and going back and looking at other history, it was clear that we did not fully understand all the flight paths that pieces coming off the tank could take and potentially hit the leading edge of the wing. So that put in place a series of tests at Southwest Research where we were actually firing foam out of a pneumatic cannon at pieces of RCC at varying velocities that were determined to be the potential relative velocities of a piece of foam leaving the tank and then going from the relative velocity of 0, being hooked to the tank, to a high velocity upwards of 700 miles an hour when it impacted the wing. And over the several weeks of testing, it became clear that a piece of foam the size that had been suspected hit the wing could truly fracture and destroy the RCC on the wing. And from that point forward, we could fill in all of the failure matrices and confirm beyond a shadow of a doubt, at least in most engineering minds, that a piece of foam departed the tank, impacted the RCC, breached the integrity of the RCC, allowing hot gases and hypersonic flow to enter the wing and eventually destroy it structurally. One of the questions that CAIB asked, and it was a good question, could we have, one, determined that we had a problem right after we got to orbit? Because we did know that foam had come off the tank. And two, if we did know something had been damaged on the orbiter, was there anything we could do that could have either saved the crew or prevented the vehicle from being vulnerable during reentry? John Shannon, one of our senior flight directors at the time, and the gentleman that finished out the shuttle program as the shuttle program manager, took that on as a classic ops problem. Clearly, a flight control team believes that there is nothing that can go wrong with a vehicle, that if we can figure it out, we can save the crew and we can save the vehicle. It's that attitude that has been around since the beginning of human space flight, probably best shown during Apollo 13, never give up. The question was painful. One, could we have known? What should we have done to find out? And once, if we had known on day one or day two, is there something we could have done to rescue the crew? Could we have gotten another vehicle ready before they ran out of consumables? John Shannon took that on. Very painful job for him and the flight control team that did that analysis. But it was a necessary thing to go do, and clearly it led to some procedures that we used for the rest of the shuttle program. Inspection when we got to space station, the pirouette that the shuttle did to look at, from the station back at the shuttle to see if there's any visible damage, the inspection with the remote manipulator arm, all of the work that was done on potential RCC repair techniques and tools to carry on future shuttle missions. So it was an exercise that needed to be done. It led to some things that probably made us safer in the future. But it was very difficult. John did an excellent job of going through that analysis. As we proceeded through the accident investigation, the NAIT was very independent in doing analysis and bringing analysis forward. The interaction that we had with the CAIB was principally through Frank Buzzard's task force that was trying to be Admiral Gaiman's interface to all of NASA. So my interface typically to the CAIB was through Frank Buzzard. I did sit down early in the investigation with Admiral Gaiman to make sure that we were on the same page and headed towards an set of answers that he would see as being accurate and with absolutely no cover-up and of the highest integrity. And that was really my goal to lay it all out for Admiral Gaiman on what we were doing. One of the things the CAIB focused on early that I thought it certainly needed to be focused on eventually, but it was very distracting for Frank Buzzard's group, and that was looking at all of the human interaction that took place after Columbia got on orbit, and the discussions of, we knew some foam had come loose, and the discussions about whether that was a problem. Should we do anything? Is there anything we can do? The CAIB spent a huge amount of energy determining that there were human errors made once we got to orbit. And you can't deny that there were mistakes made, and maybe you could have known something different than you knew in reality before deorbit. But I chose to take the NAIT to be totally technical. I did not question the decisions that were made. I figured that was somebody else's business, at least right then. I wanted to determine what happened, and in the long run, what could we do to keep it from happening again? And clearly the human interaction had to be part of that final answer. My experience with Admiral Gaiman, that he was a man of high integrity and he was out to leave no stone unturned. I thought they did an incredible overall job of pulling all of the data together and coming to a conclusion that the analysis supported. So the lesson learned that I had out of all of this, and I would share with any person that is going to be potentially involved in a major programmatic accident like this, is that you need three pieces. You need this outside agency, outside of the agency expertise, somebody with no axe to grind, somebody with impeccable credentials, like Admiral Gaiman and the people that he selected. You need that. You need the task force that Frank Buzzard led. But you also need to recognize up front, before the accident happens, that leaving the program people that have so much emotional energy tied up in the program. You need to, for their own benefit, their own sake, to establish a team of people, skilled executives and engineers, to lead that lowest level of activity, of recovery, of analysis, of putting together the pieces for the CAIB. So I would suggest that in future programmatic accident investigations, you have the makings of a team like the NAIT thought out, half a dozen people that you would be willing to put in the leadership roles of that team, and send them to the same accident investigation educational courses that we sent the guys on the ground out in the field to. I'd been associated with a number of smaller accident investigations. I had had some amount of training. I lived through Challenger. Being the lead flight director, I played in the recovery of that in an ops role, and so I learned a lot from experience. But you don't want to have to just depend on somebody's experience. You ought to give them the opportunity to have some formal training in that type work. I'd rewrite the accident documentation on how we're going to treat the next one, to include a team like the NAIT to do your day-to-day heavy lifting in the analysis and in the ops. Well, let's look a little bit into the future, and let's look at commercial human spaceflight. I have the greatest confidence that the commercial spaceflight organizations are going to find a level of success in being able to go to low Earth orbit, to take hardware to low Earth orbit, to take people to low Earth orbit. But we would be remiss if we believed that this is always going to be successful. Airlines, which we have had for 100 years, are not always successful at getting from point A to point B. Commercial spaceflight has a primary driver of being, and this isn't bad, it's just a fact, being for profit. And when you are for profit, when you're not doing what you're paid to be doing, you're not making any money. So I believe that the commercial guys and NASA or another federal agency must show the discipline, if you have a catastrophic accident, to do the difficult analysis to get to the point that you understand what happened and fix it and make it better the next time. We will not go through the full commercial cycle without losing a vehicle, without losing a crew. I mean, I pray that never happens, but when you're dealing with high energy systems that go 18,000 miles an hour or close to 18,000 miles an hour, and then have got to come back, go from 17,000 miles an hour to zero without burning up or crashing, you have the potential of having a disaster at some point in your career. So I think we as the commercial guys and we as the federal government need to set up a disciplined program to truly do in-depth accident investigation and safe return to flight analysis. I guess looking back on the NAIT, what I would take away from a personal standpoint was that the people involved, and it wasn't just the NAIT. The NAIT was not a large group. We had the three principal folks, and Jim Kennedy, Frank Benz, and myself, and we had an interface in each one of the analysis groups. These people spent almost 2 years of their life every day trying to get to the right answer. My view is that it was always done with the highest integrity and the best intentions. No one ever questioned that we weren't turning over every rock and looking under every rock and trying to make sense of all of this information that we had. I am sorry that we had to have an accident investigation team on my watch. I am proud that I was part of that accident investigation team, and the folks that I was associated with gave it everything for 2 years to prove what had happened and to try to find ways to prevent it from happening again. So I guess wish I was never part of it. I am proud that of the outcome of the NAIT and the data we provided. We were never questioned on integrity. Some people didn't agree with the data, and then we went back and had to prove it to ourselves and to them whether we were right or wrong. There was never any offense taken. We just put our heads down and worked until the answer came out the other end.